Perfect. Actually, what I'm going to talk is today is about availability groups, but availability groups in SQL Server Standard Edition. John, really appreciate the opportunity to let me present here. Really an honor. I hope everyone enjoys this session today. Actually, this session is the same session I did for Past Summit. So you went to Past Summit and didn't have the chance to go to the session. There you go. This is your choice. Okay, what we're going to cover is about everything will be related with SQL Server Standard Edition 2016 and Service Pack 1 and above. The reason that I said that is that always on availability groups was not available on the Standard Edition until Service Pack 1 of SQL Server 2016. Before that was an enterprise only kind of feature. But now, if you're running the Standard Edition, you have the benefit to have always on with some restrictions, but have always on in your infrastructure in a Standard Edition kind of environment. So one of the things we're going to talk is also a brief review of what always on technology is. So there is a lot of confusion about different ways to implement always on. We're going to try to at least clarify a little bit about the different ways the technology can behave when you talk about always on. The next thing is, right now everyone is moving to the cloud. Most of the companies are actually going to the cloud. Having a cloud, in this case Azure infrastructure, they can be backup between different data centers. Right now, in order to make, for this presentation, in order to do the demo easier or take less time, I'm going to do the implementation in two subnets and two VNets, sorry, in the same data center. But this can be done in two VNets in different data center. The only difference will be then you need to implement site-to-site VPN. But apart from that, it works exactly the same. Also, we're going to cover what are the necessary components in order to make the configuration work. So, and finally, the configuration itself. So, when we talk about always on technology, starting from SQL Server 2012 up to SQL Server 2016 and also 17, we have to kind of always on. It's always on failover cluster instance, and the way that get implemented is with one shared storage and two or more nodes. They will work as primary, one at a time. So this is what we usually know as a failover cluster kind of configuration. The nice thing about this configuration is if one of the server fails, the other will take the load. But we're still having a single point of failure that is our storage. So when we talk about always on failover cluster, we can relate that with the normal failover cluster we have seen all the time. That is multiple SQL node with one shared storage. Now the other always on that we see is the always on availability groups. The nice thing about and also failover cluster, it provides me several level protection, which means the one server fail, the other will take the load. In the other hand, always on availability groups provide me database level protection. That means if one of the instances fail, the other instance will take control and it have an own copy of the data. So we remove from here the single point of failure. In this case, we are talking about 3 nodes availability group. That is an enterprise feature because basic availability groups only support 2 nodes, and that is exactly what our next slide would say. So basic availability group limitation is 1 database per availability group. Normally, what you see in always on availability groups in the Enterprise Edition version is that you can have multiple databases in one single availability group. When you implement basic availability group, you can have only one. The other thing is the availability group can be implemented only with 2 nodes when we're talking about basic availability groups. Meanwhile, the Enterprise Edition version, you can have up to 8 nodes, if I remember properly. The other thing is, in Enterprise Edition, you can have read-only replicas, and that is not supported for basic availability groups. But there is a workaround that maybe you can use depending of your need, that is create a snapshot. So I can create a snapshot on the secondary replica, and I can read the snapshot. So if we are thinking about an environment that you usually think, I may use log shipping for snapshots, can have a better choice than shipping all the logs to a third node. So that is the other restriction that we have with availability groups, basic availability groups. Understanding Azure, how they implement their infrastructure is you logically are going to see one server under this, or one virtual machine. Under the scenes, what actually back up this logical virtual machine are 3 virtual machines. In the case of a failure, the other two can take the load. So that is really important to understand when you are creating virtual machines in Azure, because you can see that even if you have one single machine, there are more than one node supporting that virtual machine under the scenes. When we talk about this and storage, it's exactly the same. We have the disk space, and there are 3 storage that actually back up that space itself. So in case of a failure of one of the storage, the other 2 will be able to provide the data. So when we talk about Azure in just one single server, one single storage, you actually get the redundancy of 3 of them right away. Even then, what to think about disaster recovery, about performance, about how to grouping data. The next thing that most of the people ask itself is, okay, I have a drive that has a specific IOPS. Most of the time when I am on premises, I usually create a pool of disk that will serve me in multiple IOPS. And we get the throughput of multiple disk. So I can rely on my heavy processing data queries on a quick storage. That concept got also implemented in Windows with something called storage pools. Something called storage pools. So what basically happened with the storage pools is you create multiple disks in Azure. You assign those multiple disks from Azure into the virtual machine, and then you create one single disk grouping the 3 of them. Usually the kind of grouping that I use, the kind of RAID that I use to add those into the storage pool is RAID 0. And I know that sounds not very common to have a RAID 0 in a RAID, but if you think about it, you actually, for each disk you assign, you have 3 disks backing up that disk. So when you create a RAID 0 of 3 disks, what you're gonna have under the scenes backing up that RAID node is going to be 9 disks. So thinking from that point of view, it actually makes sense if you need to increase the IOPS that you're getting, or the throughput that you need for your database to create a storage pool of multiple disks. When we talk about, 1 second. Let me quickly go into the demo about how to create the storage pools. So right now I got pre-created multiple virtual machines because I don't want to spend the time of the virtual machines, of the creation of the virtual machines, but we can create the disk. So when we create the disk, we just go to Azure in the disk section. We click on Add. We click on Add. We put a name. In this case, we're going to call it disk pass 004. To the description, also the resource group. We choose the location. Try to find the location that is the same location where your virtual machine is located. This case is South Central US. The con type, if you want a standard hard drive or you want a premium the SSD kind of disk. And the source, empty disk. And then when you're selecting the disk, Azure provide you about the throughput limit that you're gonna get, the maximum you're gonna get from that specific disk. Notice how you change the size, the IOPS, and the throughput decrease or increase accordingly. So if I choose 500 gigabytes storage size, my throughput goes to 100 megabytes per sec and 500 IOPS as the most. If I increase to 500, let me increase to 300. Notice that my throughput increased to 150 and my IOPS limit will increase to 2,300 as the most. It increased to almost 1,000 gigabytes. The throughput limit goes to 2,000 and the IOPS to 5,000. I think that the maximum is 495, 4,095. Yeah, I think that is the maximum, and the maximum throughput you're gonna get on a 4 terabytes, almost a 4 terabyte size. Storage is 250 megabytes, and the IOPS limit is 7,500 IOPS. I believe that's the maximum for 4,095 gigs. Yeah, that's the maximum. Yeah. So in this case, let's say I want to create a 100 gigs disk. I just hit create, and the disk started to create. Let's see if we can start creating the other disk. Yeah. I'm going to create another one that's called disk pass. 005. And pass summit. And I will create also 100. Create. And finally, I will create the third one. It's going to be disk pass 006. Pass summit premium empty. So we have created 3 disks of 100 gigabytes each. And we have not assigned it to the virtual machine yet. Okay, again, now the 3 disks, 4, 5, and 6. 4, 5, and 6. Now, let's go to the virtual machine and assign those drives to the virtual machine itself. In this case, we're going to use VM storage pool. And notice that the virtual machine is running. So this is an online operation. So I got previously assigned 3 disks to this virtual machine. So I'm gonna assign the new ones. I got this pass 004. This pass 005. Disk pass 006. I save it. And the virtual machine itself is getting updated with the new disk. Okay. So we can go to File and Storage. We can see the disk. See that right now already have a storage pool created that is SP data that is created on 3 physical disks. There are the 3 previous one, but now I want to create a new one and notice that I have 6, 7, and 8 available to be created. So I go to the storage pools. The creation of it is very simple. Is we use a new storage pool and just follow the wizard. Storage pool data 2. So this is where creating now I select the different disk that I want to use for it. And then I create the put itself on the 2 of them. Right now, what I'm creating is, let's say, a RAID 0 kind of storage. And now I need to create the virtual disk for this storage pool that I just created. So I just right click there and follow the wizard. This is the kind of RAID I wanna have there, and I want simple because my intention here is to increase the throughput or the IOPS by the summary of the through disk. I'm not too worried about availability of the disk because I know those disks are running on Azure, and so they're running on Azure, they have a backup of 3 disks or 3 storage supporting those disks. So that is why I feel comfortable choosing simple here. In this case, I'm going to choose fixed, and I'm going to say that they're going to use the maximum size of the storage, and I'm going to create it. And the final step is create the volume in order to be used in the virtual machine. So the disk will appear at disk 9. I'm going to use all this space, and I'm going to choose the letter, I don't know, I'm going to put L. In this case, I don't know, look files. I will use, I don't know, 64K. And I will hit create. So now we notice an letter L be presented one single unit. That is the summary of the 3 disks we just create in Azure. Okay.
Kenneth, are there particular benefits for you striping those drives?
Correct. The main benefit is throughput. So if I choose, let me see if I choose here on the disk, 300. I'm just gonna add a new one just to show the example. If I choose a 300 gigabyte size disk, my throughput is going to be 150 total. If I choose 100, my throughput is going to be 100 megabytes. If I strip 3 of them, we're going to end up is at a 300 megabyte throughput approximately. So I'm going to be doubling my throughput by stripping the 3 disk itself.
Perfect, thanks.
All right. Is there any more questions about storage spaces or storage pools?
None right now. If anyone has any, throw them into the QA section and we'll get those over to Kenneth.
All right, sounds good. So what I wanted to mention is about of this option is you can increase the throughput of your storage just by stripping multiple units. So in this case, I use 3. You can use more or less. Everything is tied. The quantity of this you can assign to the unit to the virtual machine is tied to the size of the virtual machine. So it's not it's a number that is related with the virtual machines. So whatever the size of the virtual machine is the quantity of this it can have. That is, I'm pretty sure that is documented in the Azure website. I don't remember the number from the top of my head, but those numbers change very frequently. So I strongly recommend you to go and check what is the maximum drives that can be attached to your virtual machine based on your size. So in this case, I have attached to that virtual machine 6 drives plus the operating system drive. That is basically 7 in total. So now coming back to the presentation, what we actually did was to take those 3 drives presented into the virtual machine of the single drive and taking the advantage of load balancing the data between the 3 of them. When we talk about multi-subnet failover architecture, what we actually try to think about is you have a primary data center and you will have a secondary data center. So what you're trying to think about the West, when you think about this kind of architecture, you're thinking on disaster recovery. Basically, you're thinking, for whatever reason, the data center one, you can expect it to fail or will fail. So you want to have a secondary data center ready to go in case of that happening. By the way, that is a very, very unusual scenario for Azure data centers, but it's still a chance for that to happen. So when we talk about that, is the first thing that we need to cover is VNet. We need to have VNet in each data center. They will group the servers that you want to work with. In this case, like I mentioned, I need to connect those VNets, but the way that I'm going to connect them is through peering. Peering just works for one location. The VNets cannot be separate. In order to have different locations, let's say you want South US and then West US connected, you need, and instead of doing peering, what you need to do is side-to-side VPN. So you just replace this component instead of peering. You do side-to-side VPN, and it will work everything that's going to explain here. So the other thing is, in this example, I'm going to use Active Directory. So I'm going to use a local Active Directory in each site. Why? Because I want the servers to be in every data center to authenticate in case of they're not able to communicate with each other. Keep in mind, you can use another services like Azure Active Directory, or you can synchronize your Active Directory on premises with Azure Active Directory and insert there. There are multiple ways that you can coordinate that kind of security. So, you know, that part will actually have to be adjusted to your actual need. If you don't want to have Active Directory in each data center, you need to provide an Active Directory kind of communication in your local data center in order to your service to authenticate. Most of the time, it's Azure Active Directory. Also, you think about trying to have on premise always on plus a backup in the cloud. You actually will be thinking about site-to-site VPN, and probably your Active Directory on the premise synchronizing an Azure Active Directory and having your server authenticate against that. So finally, is my personal, well, finally, we're gonna have one SQL Server on each data center. And then I like to have the witness in the secondary data center, but that is a matter of taste. That is, people that would prefer to have the witness here. The thing is, if the communication fail, it's the only difference. If you have the witness on the primary data center, this is, and the communication fail, it will not fail over. If you have the witness on the secondary data center and the communication fail, it will fail over. If for whatever reason one of your virtual machine fails, that is the actual scenario that you want to cover, and the communication is still active, the witness will actually help to make the failover. So the thing is that you're looking for is an automatic failover. Where to put the witness is actually on your preference. If you believe the communication between your data center is very bad and can fail constantly, I would recommend to put the witness on the primary data center. So in cases of communication issues, you will not fail over. But if you believe the communication is stable enough, I would recommend it to have it in the secondary so that the actual failover take place. What is required in order to create this environment? First, 2 VNets in peering mode, 2 SQL Server VMs, 1 per VNet with always availability, with always on enable. Storage drive, of course. Internal load balancer. That is important to highlight. One of the differences of implementing always on availability groups in Azure is that you require load balancers, internal load balancers. Windows server as a witness. In this case, I'm using the quorum based on witness, and 2 domain controllers synchronizing, 1 per VNet. So I want to be able to my Active Directory, my database servers are able to authenticate using Active Directory. So that is the infrastructure itself, what is necessary. But when we talk about per availability group, what we need is listener name, listener port, availability group name, 1 database, 2 internal load balancer health proof ports. We're going to cover that. 2 internal load balancer rules. Important that you need to have enabled floating IP redirects enable. 2 internal load balancer front end IPs. Cluster client access point with the cluster. And you need to disable net BIOS for this address. This disable net BIOS for this address and floating IP redirect enable, those 2 settings are crucial in order to have availability groups working. The help proofs is not documented, but it's important that the help ports, they are different per availability group. Otherwise, the configuration will not work. Okay. Now, creating the network. So for those of you that had not created a network before, VNet before, let me just quickly take care. We need to create a VNet. So in this case, I got past submit VNet and past submit VNet 2. The way to create the VNet is just add you define the name, the address space, and then the default subnet and the resource group. That is the way you create it. It's nothing out of the normal. Usually I like to use address space 16 so that I can create multiple subnets. So for the first subnet, the address range is going to be 24. Then the other subnet, I'm going to put a 1, and I'm going to be 24 as well. So I got the ability to grow my subnets as necessary. Since I have 2 VNets, I need to connect those VNets one to each other. So the service that I'm doing right now is peering. So I'm saying this VNet peers to VNet 2, to VNet pass submit 2. The way to add a VNet peering is just click on the add button and choose the VNet you want to add. Keep in mind those VNet, like I mentioned before, have to be in the same location. Then once you do that, you need to go to the other VNet and you need to set exactly the same peering. The second VNet is going to peer with the first VNet. So in that way, you have a 2-way communication between 2 VNets. In this case, like I was mentioned, they are in the same location. If you want to do it in different data center that is more than expected, you need to create VPN site-to-site configuration. But that is a large example. That's example will take way more time. So in this case, I'm going to explain it just with peering. Okay, so now that you have those 2 VNets and they're peering, you have the basic of the configuration itself. So what we have right now is two data centers communicating with each other, 2 VNets communicating with each other with peering. That is the only thing we did. It is important to clarify that the first step is actually creating the VNets. Changing the VNet for a virtual machine was not supported on Azure. That is what I remember. So if you want to change the VNet for a virtual machine, actually you need to recreate the virtual machine. I understand that is something the Azure team is working to fix. They don't have fixed it now, but I just want to highlight the fact that you should create first the VNet, and then when you create the virtual machines, I should say the VNet to those virtual machines. So, so that you are able to create it properly. If you create the virtual machine before and then try to trying to check the VNet, I think that is not supported. At least that is the issue that I faced before. Next is creating the virtual machines. Creating virtual machines in Azure is, like I mentioned before, is not that complicated. Just gonna quickly go because I got the virtual machines created already. Just gonna quickly go and said what you need to specify. You click the virtual machine button, then click add, and then what you want. You want a Windows Server machine. The Microsoft already provide you what you can choose. You can choose Windows Server Data Center Edition, the different versions, the deployment model, and then you can choose here what kind of disk do you want, the username, the password, confirm the password, and resource group. The resource group basically is like a label in order to group all your resources. So that you know that when you start analyzing pricing, you said all my money is going to this specific resource group. Just provide the information. The group. See, if you already have license, you can actually save 40% of the price of the machine by bringing that license to Azure. That's what it's always. In this case, I don't have a license, so I'm going to pay full price. Then I choose the size. I can choose whatever size I feel comfortable with based on the needs of my database. So I'm going to choose in this case that configuration. Here is what you you assign the network where you want this virtual machine to reside. In this case, that is what I was mentioned, that if you set it up to a different VNet and then you try to change it later, you will have to basically recreate the machine. So first create the VNet, make sure your infrastructure is working before you actually create the virtual machine that are going to host your environment. So I click here and choose the VNet. One important feature is the network security group. So you can create network security groups, also known as firewall, that is tied to the IP itself or that is tied to the VNet. In my case, I would like to have the network security group tied to my VNet so I can control all the traffic from there and communication between the machine from there. In this case, I'm going to leave it in blank because I don't want to have a network security group for that machine. I just want it to be centralized in the VNet in order to handle all the traffic. If you want to shut downs, let's say you're thinking about a QA machine, you can say this machine will shut down 7 p.m. every day in this specific time zone. And that's it. The final step is the creation. So we are not going to do that. In this case, what we have is already pre-created a set of virtual machines that are Path Summit DB1, Path Summit DB2, Path Summit Domain Controller 1, Path Summit Domain Controller 2, and Path Summit Witness. So you may notice that Path Summit DB1 is actually on the VNet Path Summit 1 in the subnet default. and pass submit db2 is in bnet pass submit 2 in the subnet default. Okay. Of course, in those virtual machines, you need to install SQL Server. There are virtual machines that are already pre-installed with SQL Server, and you need to choose those in order to create the virtual machines. But just keep in mind that SQL Server needs to be installed. I don't want to go to the process of installing SQL Server because it's going to take a lot of time of our demo. So I'm just going to use the virtual machines as I have it right now. But before I jump on it, let's get back to the slideshow and think what we have accomplished. So before, what we have was just 2 VNets working in different data centers. And after we complete the creation of the VNs and the configuration of the network security groups, the firewalls, what we end up having is the different Active Directory, Windows and SQL Server machines. Our next step is creating the basic availability group. So far, everything is very boring. It's very normal, but I just want to go step by step. So the first thing is making sure SQL always on availability groups is enabled. So in order to make sure always on availability groups is enabled, I just go to the SQL Server Configuration Manager, right-click on SQL Server, click on SQL Server Services, right-click on the instance itself, and then there is a tab that said always on availability groups. So one of the requirements for always on availability groups is to have a cluster. So I have previously created a cluster. In this case, the cluster is named Close Pass Summit, and I click on Enable Always on Availability Groups. The step to create the cluster is just right-click, Create Cluster. It's all the steps, and you add the nodes. It's the basic normal steps to create the cluster itself. You just right-click, create cluster, and add the nodes. That's it. So once I have created a cluster, I can actually enable always on availability groups. If you don't have the cluster with the Windows failover cluster created before, you are not going to be able to enable always on availability groups. There is also a requirement about .NET 4.5, if I remember properly, they need to be installed in the computer in order to enable always on availability groups. Okay, so now that I have enabled always on availability groups in each machine, and I add the nodes to the failover cluster, I got the nodes in the failover cluster added. But to add a node is just add node. Click on the add node button. Another requirement is keep in mind the failover cluster need to be installed in each machine you want to add it into the cluster. It's a window required feature, but here we're not covering failover cluster installations. So now that you have the failover cluster configured and the nodes add, we can try to create the availability group, and that is actually where the magic starts. So just a quick reminder, well, in this case, let me try to connect to local. So just as a quick reminder, always on availability groups require your database to be in full recovery model. So in this case, we're going to try to create a new database. It's called DB4. And execute it. There we go. It's there. DB4, right? Going to try to connect to their database. Let me see if we can connect to that one. So you may notice DB4 is not there, right? So the next thing is I'm going to create an availability group. I'm going to call it, I'm going to create a new availability group. I'm going to call it AG test DB4. So what is the cluster type that we have? It's Windows Server Failover cluster. In this case, I can add the node. I'm going to leave the database there. I can create like this. I can add. Which one can I know? Let's see which one is. Two. That's how long to create the availability group. Let's try to go to the wizard. I think, yeah. Before. So in this case, the only database, what I was mentioning before is the full database, full backup is required. So when I create the database in DB4 as with full recovery model, so then I have not taken a full backup. It's running like a kind of pseudo full recovery model. So in order to fix that, what I need to run is a backup. Okay, now DB4 is available to be chosen as part of the availability group. So I can choose the replicas here. I can choose the replica. I can choose automatic failover that will require synchronous commit. In order to have asynchronous commit, you need to be, it doesn't have to be part of the automatic failover. The maximum of nodes, as you can notice, is 2. Variable secondary, the only option is no. We're not going to worry about the endpoints and the listener right now, specifically the listener. Let's SQL Server to automatically initialize. It's going to tell me the warning about the listener. Click next. And I'm going to click on finish. So this is still nothing out of the normal. What we actually end up having is normal availability group, but notice that you don't have a listener to connect with. And if you try to add the listener, actually it's going to fail. So this is, here is where these steps change. The first thing is we need to create, like I was mentioned before, we need to have an internal load balancer per virtual machine. So in the internal load balancer is this icon, these load balancers. So right now I have created 2, right? If you want to add a load balancer, you just click on the add button. This can be added after you create the virtual machine. You need to choose the IP address this is going to respond for, and it is public or internal. So in this case, you choose internal, you actually choose the VNet. It could be in this case, you need 1 per server, in this case, for the always on. And the address that it's going to use is going to be static for our needs. So you assign an address that you can use for this purpose here, and the resource group. And apart from that, everything is exactly the same. What you need for this internal load balance configuration is it has to be internal, cannot be public. Well, it can be public, but you don't want it to be public. Internal is more than enough, and then the configuration we do inside. So once we use this one, I need to define different IP configurations. So the front end IP configuration is the IP where the listener is going to respond to. So let me take notes about what addresses and what names. So in this case, I use a load balancer front end. It's going to be DB4 IP, right? It's the new one for the database that we are running. So what we do here is we just add a new one and put that name. It's going to be on the VNet path summit. The address you want to put is static. And let me just quickly check what is the next one. It's going to be 152. Keep in mind that is the IP address that we're going to make the listener to respond to. Okay. So the name is going to be DB4. and the address is 192.1.0.152 static. Okay. The other thing they need to provide the internal balancer is what is the backend pool or the backend that is going to answer to that that is available to answer. In this case, I had choose to be the node 1 of the DB nodes. So in this case, we're going to be a single virtual machine, and it's going to be this guy. Probably because I have the virtual machines disabled, it went it removed from here. But you can associate to a single virtual machine, or you can associate it to an availability set, or not associated. In this case, I want to associate it with a virtual machine. That is node 1. The other company that we want to associate with is the help proof. So in the help proof, keep in mind that you need to have different help proof for per each availability group. It's important that you have a strong naming convention here. Otherwise, it's going to be a real nightmare to manage this. So when we have the help proof, we put the name, and the next one is going to be 59.102. There we go. It's our TCP/IP. We put the port, and click OK. The last step is to associate what we just create with, so to associate the front end IP with the backend using a rule. So in order to do that, we need to create a rule. We're going to call it DB4. And we need to have a port associated with. In this case, it's going to be 902. And that's it. So we have the name. We said we're going to use this front end that we just created. The port that we're going to associate is the actual TCP port that we're going to assign to the listener. The backend port that is going to answer is, in this case, the same one. The backend pool that is going to respond is node 1. The help proof is going to be this one that we just created. Session persistent and none, and floating IP must be enabled. Keep in mind that there's a legend here that said we recommend to use this feature only when configuring always on availability groups listeners. We click OK. We run exactly the same process for the second availability group, and we do the front end IP. And the IP needs to be static. We change this to a 2 here. Okay. We add the, let me check the backend pool is working. It's unassociated because DBM was disabled. Then we add the help proof. Put the same port you put in the other one. Click OK. And finally, the load balancer rule. In order to have the load balancer rule, we need to wait until the help proof is created. Help proof has been created. So we click on add, put the name. We choose the IP different IP we just created. We use exactly the same port as we use in the previous load balancer rule in our internal load balancer. Choose the destination, the help proof we're going to use. It's not showing. Let me do it again to see if it's showing. There you go. And we choose the IP address we selected, and we create the rule, load balancer. Keep in mind to enable this, otherwise the configuration will not work. Now that we have that created, we go to the final step and actually have to take place in the Windows failover cluster. So you will notice here that in the roles there is a new role that is called AG Test DB, but AG Test DB doesn't have more than the name of a resource. We need to add client access point. We need to add a new client access point. And this client access point is going to be listener. Let me just to keep the same naming convention. ID D1. Okay. ID DB 4. Of course, it says I have two VNets, as I said in the cluster configuration. It's going to pick part of them, and then this is created manually. I like to keep the same naming convention here, so I'm going to choose the same names for the network. So now I have those two. And this is the second data center. This is the first data center. So I'm going to put this name, but it's going to be 152, right? And it's going to be static. And guess what? Here we're going to put 152. What's the IP that we defined there? We click on apply. And we'll click OK. Now, let me see what names do I have here. All right, I feel more comfortable with this. Sure. Okay, just change the name. Which is this guy here. Oh, one sec. Isn't this one? Choose this guy here. We set exactly the same static 152. And disable net BIOS for this address. Click OK. Finally, we load PowerShell. Have to be as an admin. And we have to run that script that is actually in the PowerPoint presentation. And what we do with this script is we set the cluster network name, that in this case, for example, is data center 2. The resource names, we take those values from the failover cluster. We didn't change the names. Do test 1. Test 2, data center 2. Doesn't want to change the name of the resource. We'll try to bring it online. Okay, now I change it. The other thing is, in order to make this happen, is to add a dependency here to the IV DB4. Oh, it is offline. Now we add the dependency. And now we have the dependency created. Finally here, we choose the network, but in this case is, I got 2 networks, is data center 1 and data center 2. So I choose the network. This case is data center 2, and I put LDB4 DC2. The IP address is 52, and the proof is 902. I run this, and it creates the necessary communication between the internal load balancer and Azure in order to make the listener to work. So now I do exactly the same for data center 1. And it just tells me that the resource needs to restart. So I can go to the nodes, go to the roles, bring this guy, take offline, and then bring it online, and it will be created. So now, when we go to the always on availability root configuration, the node 1, we're going to notice, let me refresh here, that we have a listener that was They was not there before. Finally, we open the listener and we put the port to be defined in the availability group, in the internal load balancer group. And in that case was 49,902. And I can connect to this gentleman. Or is let's see something filling here. Probably name is down. Okay, let's see the one name. Unable to connect. I just was putting the run listener name. Unable to connect to the database. I just created the availability group. So just to explain a little bit, what you're putting here in the PowerShell script is the network name and the data center. And I lost the presentation. 1 sec.
Hey, Kevin.
Yep.
Thanks for definitely a great session here on going end to end on exactly all of the little pieces that go towards connecting to get this work out in Azure. That's amazing.
Well, I'm glad you like it. It is a long session, but we got it actually working. The trick here is this PowerShell script. I'm making sure the settings I mentioned before about the disabled net BIOS and the floating point on the internal load balancer are set up.
Yeah, no, I mean, this is definitely a great video. I think a lot of people are going to reference once we get it out on the YouTube channel to go step by step to figure how to get everything together. It's definitely not a real simple, trivial task.
No, actually, first time I configured that, took me a lot of time. There is a lot of caveats that need to be worked out.
Yep. So we did have a few questions in the queue. I'll start with the easiest one, the PowerShell script that you have. Is that something you can make available, and is that how you fully sync up the listener?
Sure. The PowerShell script that I have is, yeah, I can deliver it to you, or people can write me in order to get it either way.
Okay, perfect. And then through the load balancer, can you use just one load balancer for everything?
It depends. For example, if you have in different, if you're planning to be in different VNets, that is what we call a multi-subnet failover. If you want different VNets, no, you need to have one load balancer per VNet. If you're going to have your two nodes in the same VNet, yes, you can use one load balancer for everything.
Perfect. All right. I think that's it for all the questions here. A couple people said, thank you, great job, very complicated thing. So yeah, thank you once again. And like I said, we'll get the recording out there so people can watch this over and over again to build their checklists on how to get this done.
Perfect, perfect. John, thank you very much to give me the opportunity to present here. I mean, it was really, really nice. I know that I run a little bit over the time, but sorry about that.
No worries. No, definitely worth it to get the whole process down for everyone. So with that, we'll go ahead and we'll close out the meeting here today, and we'll catch everyone next month.
Absolutely. Bye.